This is chapter 1 homework video, including numbers 67, 68, 72, and 74. So here we go with number 67. Now, I really recommend for this one that everyone get started by pausing this video and seeing if you can figure this out. It's saying to find an equation. So what's the parent? What's the shape of this going to be? And so see if you can figure it out on your own. This is a good time to test yourself. So let's go over how or the thought process for doing that. Um, this one right here, I see that the locator point is here. According to this shape, I see there's some asymptotes going on right here. This is a reciprocal graph, so I know it's got this kind of thing going on. I see that from 0, 0, the center is moved over 2 places to the left, so I know that that's a +2, and it needs to be under there, being in parentheses with the x, and it was also moved down 3, so a -3. So this is a possible equation for that graph, and I see that this goes through 1 unit over and 1 unit up from the origin or the locator point, so we're set with that. All right, on this one, I see a parabolic shape, so I know it's going to have an x squared. The vertex or locator point is here. It was moved over 2 spaces to the right, so that makes a -2, and it's squared because it's a parabola. It is upside down. It's not stretched or compressed. It's a normal width and shape, but it's got a -1 or just plain negative in front. And then it was also moved up 1. So there's the +1. There you go. I hope you guessed it right before you saw me do it. All right, on this one, another one of these graphing problems. Burton travels on cruise control 50 miles per hour from 2 o'clock to 5 o'clock. How far does he travel? So this is 50 miles per hour for how many hours? From 2, let's see, 2, 3, 4, 5, that's 3 hours. So 50 times 3, the hours cancel out, and that means we traveled 150 miles. B, sketch the graph of the previous information using velocity in miles and time in hours. Shade the area under the graph in the first quadrant. What shape is the shaded area? And explain why it represents 150 miles. Ah, see, there's the answer. Oops, I forgot to put the 0. They match. Okay, so if we sketch a graph, one axis will be our hours, and the other will be miles per hour. Well, this is pretty easy to scale because I'm just going to put 50 right here. Let's scale it by 50s. There's the first mark. And then 1, 2, 3 hours. 1, 2, 3 hours. So cruising along for a total of 3 hours at 50. That's exactly what the graph would look like. And then it ends right here after 3 hours. So this shaded area represents the distance traveled, and I can see that it should match. It's got 3 times 50, base times height. It's an area problem. Area under the curve can represent distance. So 150 because of base times height. Next one. Okay, solve the following equations. All right, I'm going to pick a couple and you do a couple on your own. Let's take a look at D together. First of all, all of these, let's see, this one's not quadratic. These two are quadratic, and this one's cubic right now, but we're going to be able to factor that. So we're going to need either factoring or quadratic formula for these two. And this one, probably just starting with distributive property and simplifying and getting all the x's together, numbers together. So I'll leave you to that one. Let's take a look here at D. So I'm going to make sure to get, since I know I'm going to end up with a quadratic, I want everything on the same side of the equals sign. So I'm going to subtract the 6x from both sides and end up here. Now, let's factor out an x. So I end up with x squared plus 1x minus 6. There, that's much better looking. So I can factor this one more time. And this factors into a positive 3 and a negative 2 here. All right, so since it's a cubic, I have 3 solutions. So what is this if it's set equal to 0? Well, x would be 0. That's one solution. What is this set equal to 0? Or what, in other words, what makes all of this equal 0 if x were a negative 3? And for this one, what makes this all a 0? That would be a positive 2. So those are the 3 solutions. This one here will have 2 solutions, this one will have 2 solutions, and this one will have 1 solution. Just to check your work, you should end up with negative 37 here. So if you get something different, go back and try it again. All right, the last one, number 47, solve this triangle. So another review on finding all of the parts of a triangle. So I can see by looking at this that this is a 30, 60, 90 right triangle. And that's because here's my right angle, my hypotenuse is 16, and my short leg is 8. So if you imagine using this line as a line of reflection and flipping this triangle over to this side, oops, this would also be 8, and this would match at 16. 8 and 8 is 16, so this is, would you agree now, all of it together is an equilateral triangle? All of those angles are 60 degrees, so that means this is 60 degrees. So if we go back to the original, this one must be 30 because all of these angles have to add up to be 180 degrees. Now, if you can remember the 30, 60, 90 pattern, it's always this value times 2 and this value times the square root of 3. So this side length is 8 radical 3. And that's it. Bye.